Welcome back to my YouTube channel guys. Today we will study about covalent bonding. If you don't understand this chapter, then watch my videos about atomic structure and ionic bonding, links in the description below. A covalent bond is a bond formed by the sharing of electrons between two atoms. When atoms combine by sharing electrons, molecules are formed. Note: covalent bonds can be formed between atoms of the same element and atoms of different elements. Molecules of elements: how electrons are arranged in the molecules of elements. Some elements exist as molecules, for example hydrogen, chlorine and oxygen exist as diatomic molecules. Each molecule of these elements is made up of two atoms that are joined together by sharing electrons, or by a covalent bond. We can show the formation of covalent bonds by a dot and cross diagram. Dot. Cross. Two hydrogen atoms. A hydrogen atom has one outer electron. It needs one more electron to attain a stable duplet electronic configuration. One hydrogen molecule. A hydrogen atom shares its outer electron with another hydrogen atom. A pair of electrons is shared between the two hydrogen atoms, thus a single covalent bond is formed. Another way of showing the dot and cross diagram of a hydrogen molecule is this. A single covalent bond or a single bond in a hydrogen molecule is represented by a single line, as shown by H, one covalent bond, H. One covalent bond, H, is the structural formula of hydrogen. H2 is the molecular formula of hydrogen. Two chlorine atoms, one chlorine molecule. A chlorine atom has 7 outer electrons. It needs one more electron to attain a stable octet electronic configuration. A chlorine atom shares one of its outer electrons with another chlorine atom. A single covalent bond is formed. Another way of showing a dot and cross diagram of a chlorine molecule is this. Cl, one covalent bond, Cl, is the structural formula of one chlorine molecule. Cl2 is the molecular formula of chlorine. Two oxygen atoms. An oxygen atom has 6 outer electrons. It needs 2 more electrons to attain a stable octet electronic configuration. One oxygen molecule. Each oxygen atom shares two of its outer electrons with another oxygen atom. two pairs of electrons are shared between the two oxygen atoms, thus a double covalent bond is formed. Another way of showing a dot and cross diagram of an oxygen molecule is this. O, two covalent bonds. O is the structural formula of oxygen. O2 is the chemical formula of oxygen. One oxygen atom. An oxygen atom has 6 outer electrons. It needs 2 more electrons to attain a stable octet electronic configuration. Two hydrogen atoms. Each hydrogen atom has 1 outer electron. It needs 1 more electron to attain a stable duplet electronic configuration. One water molecule. An oxygen atom shares 2 of its outer electrons with 2 hydrogen atoms. 2 single O-H bonds are formed. Another way of showing a dot and cross diagram of water is this. O, covalently bonded with 2 hydrogen atoms, is the structural formula of water. H2O is the chemical formula of water. Chemical formula of covalent substances. Writing the chemical formula of molecules of elements. If we have to write the chemical formula of a diatomic molecule, 2 atoms, we simply add a subscript, 2, after the chemical symbol of the element. For a triatomic molecule, 3 atoms, we use a subscript, 3. Some molecules of elements have too many atoms, so their chemical formulae are represented by the chemical symbol of the element. For example, a molecule of sulfur has 8 sulfur atoms, but it's represented by the formula S, and not S8. Writing the chemical formulae of covalent compounds, we can derive the chemical formula of a covalent compound from its chemical name. The chemical name of a covalent compound usually indicates the elements present in it, may contain a prefix. The prefix tells us the number of atoms of the element. What is the chemical formula of sulfur dioxide? Sulfur dioxide is made up of the elements sulfur and oxygen, sulfur dioxide. We assume the first element named, sulfur, contains only 1 atom unless otherwise stated. The prefix, di, indicates that there are 2 oxygen atoms. SO2 is the chemical formula of sulfur dioxide. What is the chemical formula of dinitrogen monoxide? Dinitrogen monoxide is made up of the elements nitrogen and oxygen, dinitrogen monoxide. The prefix, di, indicates that there are 2 nitrogen atoms. The prefix, mono, indicates that there is 1 oxygen atom. The chemical formula of dinitrogen monoxide is N2O. Structure and properties of covalent substances. Covalent substances exist as simple molecular structures, giant molecular structures, simple molecular structures. Simple molecular structures have simple molecules. For example, bromine. Bromine has low melting point, -7 degrees Celsius, and low boiling point, 59 degrees Celsius. Physical properties of substances with simple molecular structures. Substances with simple molecular structures have low melting and boiling points. Diagram of bromine. Bromine molecule. Weak intermolecular forces. Strong covalent bond. The bromine atoms are held together as bromine molecules by strong covalent bonds. However, the bromine molecules are held together by weak intermolecular forces. The weak intermolecular forces can be easily overcome. As a result, bromine has low melting and boiling points. Bromine is volatile, it evaporates easily. Substances with simple molecular structures are usually insoluble in water and soluble in organic solvents. For example, oil dissolves in dichloromethane, an organic solvent, but not in water. Most substances with simple molecular structures do not conduct electricity whether in the solid, liquid, or gaseous states. This is because simple molecular substances do not have any free-moving ions or electrons to conduct electricity. Giant molecular structures. Giant molecular structures exist as a giant network of atoms that are covalently bonded. Examples of substances with giant molecular structures are diamond, graphite and silicon dioxide. Diamond and graphite are allotropes or different forms of carbon. Physical properties of substances with giant molecular structures. Substances with giant molecular structures have very high melting and boiling points. Giant molecular structures have a large number of atoms which are held together by strong covalent bonds. A large amount of energy is required to break these bonds, for example, heating or melting the substance strongly. Due to their high melting and boiling points, substances with giant molecular structures are solids at room temperature. Substances with giant molecular structures don't conduct electricity. In giant molecular substances, except graphite, all the outer electrons of the atoms are used to form covalent bonds, thus there are no free electrons that move through the structure to conduct electricity. Substances with giant molecular structures are insoluble in both water and organic solvents. This is because all atoms are held together by strong covalent bonds. No forces of attraction are strong enough to break these strong covalent bonds. An example of giant molecular structure, diamond. Diamond is one of the allotropes of carbon. Due to its exceptional hardness, it has high melting and boiling points. Take a look at its physical properties. Carbon atom. Covalent bond. Structure of diamond. Diamond is hard and has a high melting point. Each carbon atom is covalently bonded to 4 carbon atoms, which in turn are bonded to 4 more carbon atoms. This forms a 3-dimensional structure. Diamond does not conduct electricity. In the diamond structure, all the outer electrons of the carbon atoms are used for bonding, thus there are no free electrons that move through the structure to conduct electricity. That's all for now. Give this video a thumbs up, subscribe to learn with us, and don't forget to press the bell icon. See you in the next video. Goodbye.